Continuing with Chapter 14 and probability, it's important to know the first three rules of working with probability. And if you can guess, yes, they are make a picture, and make a picture. So again, first three rules of working with probability, no different than the first three rules of working with statistics, make a picture. The most common picture that we'll end up using is going to be a Venn diagram. As shown below, and the man in the picture is Venn, the guy who actually came up with Venn diagrams. Equally likely outcomes. When probability was first studied, they looked at games where each outcome was equally likely. For example, rolling a die is 1 out of 6. So 1, 2, 3, 4, 5, or 6 could come up. Picking a card from a deck of cards. You have 52 cards in the deck, you pick one, you have a 1 out of 52 chance of any one card coming up. However, random events are not always equally likely. Outcomes are not always equally likely. When that's the case, we have to follow rules when dealing with probability. So this leads us to formal probability. When talking about probability, we want to be precise. The simplest way to deal with probabilities is to base the calculations on individual outcomes. If we are concerned with an event rather than individual outcomes, again, we need rules. The first rule for probability is that if the probability is 0, then the event never occurs. If the probability is 1, then the event always occurs. Again, we said this before, but probability has to be a number between 0 and 1. So for any event A, the probability of that event is in between 0 and 1. The second rule is the something has to happen rule. When you flip a coin, even if you want it to come up heads, it's going to be heads or tails. Something has to happen. When you roll a die, something has to happen. It's going to come up 1, 2, 3, 4, 5, or 6 because you are actually rolling the die. We need to distribute the probabilities among all of the outcomes a trial can have. For example, if your drive has 3 possible outcomes, you have to go home after school, or at least some point you have to go home. So you're going to take one of those 3 routes. One of them is going to happen. So you could take Route A, Route B, or Route C. We are sure that one of these outcomes will occur, giving the probability that something will happen at 1. So you will go home, you will make it there, so you going home, there's a 100% chance that will happen. You put all of the possible outcomes into the sample space. The sample space is denoted an S, and the probability of the set of all possible outcomes must be 1. So you know that all of the outcomes combined have to equal 1. If you combine all of the possible outcomes and you don't get 1, then something is not right. Again, here using probability notation, you have the probability of the sample space, something has to happen, is equal to 1. The third rule is the complement rule. So this does not mean that you have to compliment me when you come to class tomorrow, but instead the complement rule means that it's everything else. So you can subtract from 1 is essentially what the complement rule means. So for example, if the probability of you getting to class on time is 80%, then what's the probability you are late? Well, you're either going to be on time or late. So if you're on time 80%, then you are late 20%. You just have to subtract it from 1. So again, here, event A would be getting to class on time. The set of outcomes that are not an event A is called the complement of A, and it's denoted with a capital A and then a C as like an exponent. The probability of an event occurring is 1 minus the probability that it doesn't occur. So again, the probability of A is 1 minus the complement. So again, using a picture, a Venn diagram down here, if the green circle is event A, the complement is everything else around it. The fourth rule is the addition rule. Suppose the probability a student is a sophomore, we'll call this A, is 20%, and that they are a junior, we'll call this B, is 30%. What is the probability that the student is either a sophomore or a junior? In that case, we just add them and we get 50%. So what the addition rule says is that you can add the probabilities of events that are disjoint. So we need to identify what disjoint means. Disjoint means that they have no outcomes in common. This is also called mutually exclusive. So you can't be both a sophomore and a junior, so those are disjoint events. Again, disjoint is when events have no outcomes in common. Using proper notation, we have the probability of A or B. The U symbol, without a tail on the U, means or. So this symbol right here is or. So A or B is equal to the probability of A plus the probability of B, provided that A and B are disjoint. So again, in our Venn diagram that we have down here, note that event A and event B do not overlap. That's because you can't be both a sophomore and a junior. There's no way to overlap in that situation. So they are completely separate. That's also how we can tell that they are disjoint. By the something has to happen rule, the total of probabilities of all possible outcomes must be exactly 1. You can add the probabilities to check that the sum is exactly 1. For example, the probabilities of selecting at random a freshman, sophomore, or junior are 25%, 23%, 22%, and 20% respectively. This is not legitimate probability because the sum is only 90%. So something is wrong here. So this actually would not work. And again, we can use the addition rule to check that all of the possible outcomes are exactly 1. The fifth rule is the multiplication rule. For two independent events, and again, the fact that they are independent is extremely important here. And again, independence means that one outcome will not affect the other outcome. So event A will have no effect on event B. For two independent events, A and B, the probability that both A and B occur is the product of the two events. So as we can see here with the proper notation, using the P for probability of A, and then the upside down U means and. So A and B is the probability of A times the probability of B. So for example, what is the probability that you get 2 heads in a row if you flip a coin? Well, the probability that the first one would be heads is 50%, and the probability that the second one is heads is also 50%. When you multiply them together, we get 0.25 or 25%. And again, here we can see in a Venn diagram, A and B are overlapping because both events can occur. So we have event A, event B, and then this area in between where A and B can happen. And in this case, these events are not disjoint because they do overlap. Calculating probabilities. In most situations where we want to find a probability, we'll use the rules in combination. A good thing to remember is that it can often be easier to work with the complement of the event that we're really interested in. Helpful hints: the word not means to subtract from 1. So if you see the word not, you're going to want to use the complement. That's where it's indicating that it's going to be easier to use the complement, and you're going to subtract from 1. The word or means that we add, and the word and means that you multiply. Now, in all the problems that we'll have, they're not going to specifically say or specifically say and. Sometimes they will, but sometimes you're really going to have to think about the scenario and talk it out in your head to see what word makes more sense, and or. So what have we learned here? We've learned that probability is based on long-run relative frequencies. The law of large numbers speaks only of long-run behavior. So you want to watch out for misinterpreting the law of large numbers. There are some basic rules for combining probabilities of outcomes to find probabilities of more complex events. We have the probability assignment rule, the complement rule, the addition rule for disjoint events, and the multiplication rule for independent events. So again, the probability assignment rule is that something's going to happen. It's going to have probabilities. The complement rule is where you subtract from one. The addition rule means that you can add them together as long as they have no outcomes in common. And the multiplication rule is when you can multiply the probabilities as long as one event doesn't affect the other event. We're going to do some examples tomorrow in class together, but that is it for tonight, and I'll see you tomorrow.